The video will demonstrate how to treat exposed soil abutting a building's footer using the trenching method. Example product used in this video will be Termidor HE. The building has an exposed slab edge as its current termite management system. In most cases, an exposed slab edge is a sufficient termite management system in conjunction with annual timber pest inspections. However, in this case, the driveway bridged over the exposed slab edge, and then the garage required protection via chemical treatment. Before beginning a chemical soil treatment using the trenching method, you should carefully prepare the worksite. Start by reviewing the work order to confirm the treatment requirements and scope. Next, locate the treatment site and ensure clear access. A full risk assessment must be conducted, including checking for underground cables, plumbing and utilities at the meter box. Always check the meter box and the certificate of installation to identify any termite management systems previously installed on the property if possible. Any hazards identified should be managed through appropriate control measures to protect people, property and the environment. Finally, calculate the treatment area. In this case, it is a 6-metre section. You'll then need to determine the soil type, which in this case is a sandy loam. You will also need to know the footer depth of the building. Insert a metal rod into the soil until you hit the footer edge. In order to treat the soil, you will need to remove the soil that is abutting the footer. In this diagram, you can see you'll need to create a trench 150 millimeters wide and at least 80 millimeters deep. As I don't know which Termidicide product your workplace chooses to use, we will use Termidor HE as a case study. We will work together looking at the label, calculating the case study's area, and determining the volume and mix rate. It's very common that you'll need to use multiple methods of treating the soil around a building structure. This means drilling and injecting may come in contact with your trenching. When this occurs, ensure that you have even continuous treated zone to ensure there are no gaps that termites can gain access to the building. What we know so far is that the building footer is 100 millimeters from the leveled soil to the edge of the footer, and that the length to treat is 6 meters. Chemical manufacturing companies often will provide a cheat sheet to help you determine how much volume of emulsion you are requiring for the site. To work out the volume of emulsion required, you first need to consider the cubic meters of soil you'll be removing. To do this, times the width by the depth by the length of your trench. Ensure your equation is converted into the same units to get the correct answer. For the width, which is 150 millimeters, divide this by 100 to get 0.15 meters. The label states that the treated zone must extend 50 millimeters below the top of the footer, so add your 100 millimeter footer depth to 50 millimeters and divide this by 100, which equals 0.15 meters. Times the answer by 6 to get your cubic meter of soil. So for this case study, you have 0.135 meters cubed of soil. The label of this product tells you to apply at least 100 liters of prepared spray per cubic meter of soil. So you now need to times your answer by 100. This means you need 13.5 litres of prepared emulsion to trench a 6 metre length. The dilution rate for this product is 625 millilitres per 100 litres of water. So you need to divide 625 millilitres by 100. You now need to calculate your mix rate. So 6.25 millilitres times 13.5 litres, which is your required volume, equals 85 millilitres of concentrated Termidor HE. Shane has now put 13.5 litres of water into his bulk tank and is measuring out his 85 millilitres of concentrated Termidor HE. He'll pour this into his bulk tank, agitating well. Shane always practices safe chemical handling by wearing the required PPE, measuring on a level, stable surface, and ensuring containers have their lids put back on and stowed away in a safe place with the adequate funding to prevent accidental chemical spills. Ensure adequate signage is out to warn people of the hazard and always have a spill kit nearby. Next, Shane marks out his 150mm width of the trench he must dig. When using a shovel, always practice safe manual handling techniques. To ensure you have a happy customer, carefully remove the top layer of grass, placing it next to the trench edge to return later. As you are digging, remove any rubble, as in stones or tree roots, to ensure the termiticide can bind to the soil well. Termites only need a gap of 1 to 2mm to bypass the treated zone and enter a building. Once you've finished digging your trench, start your pump in a well-ventilated area and prime your hosing to ensure termiticide is all the way through to your injection rod. Using a wide fan nozzle, apply the termiticide to the base of the trench at the rate required by the label. Use a flow meter to determine their volume as you go. Backfilling is achieved by pushing the existing soil back into the trench by backfilling. In this case study, Shane only needs to backfill the trench once. Once the backfilling is complete, the soil will then need to be drenched with termiticide as per the product label. This ensures no gaps and a consistent chemical treated zone. To ensure a high quality job and increase your customer satisfaction, return all of the landscape material as you found it. Scarify the soil into the product